project is the modeling, testing, and the simulation of a custom-made 3D printed back support device. And I did this with Dr. De Guzman. So, sorry. The goal was to make a custom 3D printed device that could support the lumbar or the lower back of the spine, specifically for cases of a spinal cord injury. And this is a great idea because 3D printing is relatively inexpensive and it can help provide customized support, which is much better and easier for patients after going through a surgery. And we hope that using 3D tools like modeling, printing, and simulation will help us achieve this goal. So the primary method that took us to get there is to first design the project and then test the functionality of it. So my main goal was to make the design in a 3D model and then print it, find the best 3D printing parameters to print it in, and then mechanically test it and then report the results in our journal article. So first of all, we made the custom back support model in Autodesk Fusion. And to do that, I used my own back to custom make a back support for myself. So I used a spline, which is this little line that follows the curvature of my back, and all of my size requirements in order to make a customized back support for myself. Then we used CheetahBox, which is kind of like the middle ground between the modeling and the printing. And we used 3 different infill densities of 10%, 20%, and 40%, which is the amount of material inside to test what's the best amount that we can use. And we had to split it in half in order to make it easier to assemble and to make it fit in our printer. Next, we used the Saturn 4 resin 3D printer to print it, and here's what it looked like. And the resin printer used water washable resin, which is inexpensive, and it uses a TPOL photo initiator to create this acrylate-Macromers reaction in order to get our result. And afterwards, it took about 13 hours to make one side and about $7 to make one side. And resin 3D printing is great for making any kind of these models. So then we had to mechanically test our data, and we used the Mark 10 to compress and to mimic the bending of the back. So we compared the displacement to the force of each of our infill densities, and we compared the displacement at a force of 50 to get the projected displacement for each infill density from 0 to 100. And we found that 34% is the best stress, the best infill density that we could use, as it is enough, as it has an ultimate stress of 120 kilopascals, and that is enough to withstand the bending of the back. Then we put this into a computer simulation called COMSOL Multiphysics, where we basically meshed our design and had the computer simulate the compression of our design to create this, which unfortunately isn't working. But it is basically a simulation of the comparison of the von Mises stress versus the mechanical properties of our design to show you the stress of the model as time progresses. And we get this graph, which didn't match, but what we did is we adjusted the ratio, and we got a match in our computer simulation to our real experiment, which essentially means that we can use the computer simulation to mimic real-world environments to see how our design would react in the real world. And then we use these material properties to make sure that our computer simulation matched up to our real-world properties. So last thing is we assembled it. We had to assemble the 2 halves. We attached memory foam for extra patient comfort, and we used belt straps to secure it in place. So the overall cost of our device is $47 in comparison to the conventional device, which is upwards of $200. It took us 2 days to make it, and in comparison to 1 week that usually takes to make the actual device that people currently use. And we have a custom patient fit in comparison to the 3 sizes that are only available for people. So 3D printing and modeling and our film simulation was great to create our custom-made lumbar support device. It was inexpensive and faster to make, and it is very functional in creating enough support to support the back after surgery. And in future work, we hope to create more iterations and to get more data on our designs, include more patients, and also have a journal article publication. Thank you to everyone.